My voice any better now? Hope so. Let me know. Let me know how it is. Okay, that's great. Really good. Really good. Oh, crap. Okay. I'll link the thing in the announcements. Add student. Okay. Awesome. So the purpose of this lesson is to talk about all things about strings, all the cool things that I know about string, and how much power it has in C#. Well, it's quite similar in other languages as well. But being aware of what you can do with a string is quite important. So this is the purpose of this lesson. And really, what you learn now will not be any more advanced in the future. I'll try to teach you all the things about string that you should be aware of. And we will talk about stuff like the performance differences, where the performance can be as different as 1,000 times using different methods for same result. So I think this is really useful, and let's get started. Since most of this is purely code and there is nothing difficult to understand, it's just knowing how to do things rather than getting a hang of a concept, I won't be having slides. Today I'll be showing lots of different pieces of code and we'll be working through that. So I hope that's fine by everyone. So I think I'll start from... Did the stream stop? Really? Okay. So we'll start from where we left off last time on some lesson. And the part that I wanted to show is, remember I mentioned that we shouldn't be comparing strings as is. Comparing strings is dangerous because sometimes it might not be as you expected. But actually, I was not completely right. So in lesson 2, I think, I said that comparing strings with equality might result in a false, which is true, but it's true only in very rare cases. So I can debug this part. Or maybe, yeah, I can debug this part so we see how it works. Right, put in debug mode. So we have two strings and both are the same strings, A and A. And then we have another string, which is an object. So if we compare A1 to A2, just like that, we get equality. I'll pin it actually. So comparing A1 to A2 results to true. If I compare it with equals, it's absolutely the same. It's still true. Now, however, if I compare A1 to A3 with equality sign, it will not result in true. sorry, it still results in true, but if I compare A2 to A1, A1 to A2. I'm a bit confused now myself. It shouldn't have been like that. I think if I made those objects, it's not exactly what Joshman said. There are differences, and in some cases it won't work, and in this case it shouldn't have worked. Let me try one more thing. Object A4 is A2, and let's do the comparison. Well, there are two cases, and it's super rare. It's still true. False only when you do this, but this is obviously false. Okay. Okay. Anyways, my point was that when you compare strings with values, so if this is a string and if this is a string, you'll most likely get a string as a result. And I mean, when comparing two strings, you'll have a value comparison always. And if you compare objects which are strings, in some cases, some weird cases, you might get a true or false. In some cases you might get a false because they will start comparing references and they will have a mismatching references. But in this case, I quite failed at demoing that. Maybe not. Let's try one more thing. Object. But my point is that it's not horrible to compare strings like so with an equality sign. Equals should only be used in very generic methods. And since you don't know that yet, it's no problem. So A3 and A4, it's still true. Okay. I cannot demo it now, apparently. Anyways, let's continue. Next thing that I wanted to show is equals. So I told you to use equals, but be careful how you use it. If you compare two strings with equals, prefer to compare it with the static method, with string equals, rather than this equals method. Because the difference is that this one will fail if a string is null. So if I debug again, you see I made A1 to be equal to null. And so, the comparison like this succeeds, like this it succeeds, but this one gives me an error because A1 is null. So if I compare it, it gives a null. I'll zoom in as well because why not? So don't be afraid to compare strings like that. It's not as bad in C#, that's my point. And I tried really hard to mess the comparison of strings up, but I still got a positive result. So it's an edge case if you face one, and if you face one, then fix it. It's 1% of all the cases you will ever face that string comparison fails like unexpectedly. So it's fine to compare it like this. It's really fine. Now, another thing I wanted to show that is also already familiar for most of you who have been doing homework is parsing. Parsing strings into stuff, and people used into numbers, and people use different things to do that. So, for example, if we have a numeric string, and we want to see what happens if we parse it. So with parse, this fails. With try parse, it will return false. And with convert, if it's not a number, it will return it will throw an exception. Let's put the breakpoint. And before this lesson, I actually had a misconception. I thought it would return 0, but it returns it throws an error. So parsing 1 returns 1. That's normal. Parsing word when it's successful also returns. Well, if it's not successful, it returns false, and 0, the default value of int. And parsing a numeric string with convert also works, but with a word that's not a word, it doesn't work, as you see here. So my point here being, if you don't know if a number can be parsed, parse it with try parse, because with this one you can check if the number can be parsed in the first place. Now for string is null or empty, if you're working with a string, check if string is null or empty. But for parsing it with try parse, it's not necessary, because even if it's null, even if it's empty, it will not give an exception. It will simply return the result false. So try parse handles that. Don't worry about it. We can try it if you don't believe me. So as you can see, return is false, and try parse, the result is 0 again. And now let's move on to the things that are quite interesting, that are quite new and interesting, but very useful nevertheless. So formatting numbers, formatting dates, formatting in general is a pain sometimes, especially if you don't know what you're doing. And in fact, it's an interesting topic, because sometimes you might not notice this problem until you go international, because different cultures have different formatting, and by default the formatting you're having will be the formatting that comes from your own system settings. So whatever I have in my settings will influence what I have, what output I'll have when formatting numbers in different ways. So the first thing that I'd like to show is string interpolation. Before, we had a sentence formatting like this. So if we wanted to say that, for example, we have name and position or profession maybe. So if we have name Tom and profession firefighter, we would say, we could build a sentence like this, like name, let's say this person is name, his profession is and then I would say firefighter, profession. So this is how you would format a sentence before. But C#, and actually this is quite, I wouldn't say unique to C#, but not all languages have this. I think Java doesn't have this. C# has a thing called string interpolation. So instead of writing a sentence like this, I can write it like this. And it will be, I'll just copy paste this so that it's exactly the same. So you don't need to add strings together. You can do something like this. And this is equivalent. These two lines are equivalent. And let's have a proof that they are equivalent. Sentence, sentence. So if I run this now, build errors. Where do I have build errors? Right. So as you can see, we just ran this and the lines are exactly the same. And readability is way better. And yes, a good point that Antero made. This is essentially also the same as, literally the same as, sentence is misspelled. Correct. This line is the same as this. So if I did string.format, this is the old way of doing it. So instead of name and profession, I would put 1 and 2, and then in the end I would put name and profession. And then I don't need this. And this is the old way of doing things. However, this exists in more languages than the string interpolation. String interpolation exists in C# as far as I know, and I think in JavaScript in some form. But string format exists in most languages, also in C++, in Java, and other. So if I did, again, the sentence print, I would have, again, the same result. So you can see these are the 3 lines written differently, but all output the same result. So the difference, this compiles into this. As simple as that. That's all. So that's string interpolation, and from now on, if I see people writing like this or like this, I will not be happy, and I'll ask them to rewrite it to this, because this is the only logical way of writing strings, concatenating strings, formatting strings when you want to insert another string in them. Speed-wise, it's absolutely negligible, irrelevant. These two are performant, so don't worry. This is probably the slowest one of all, speed-wise. I will show you, however, what to do when you care about performance quite soon. So formatting string is done like this. Now, that's just not formatting in general, but writing a string, inserting a string, concatenating strings. Of course, if I wanted to, let's say, put 10 spaces, I could do it in an interesting way. So writing a minus sign either here or there will give an interesting result. Actually, so here I wrote a minus, here I'll write a plus. Any guesses what this does? What this does is actually quite interesting. Where I write name, it will put 10 spaces after the name, and where I write profession, it will put 10 spaces before the name. And this is the equivalent. So if I run this again, sorry, the other way around. Yes. Profession is firefighter. It should have put spaces, but it didn't. So as you can see, before Tom we have 10 spaces, and minus sign will put it ahead. But now I'm wondering, why is it not putting it here? Why is it not putting it profession is firefighter 10 spaces? It put it before Tom, but not before here. That's so odd. Period after firefighter. Forgot to put period after firefighter, forgot to put period after firefight, period after firefight. I don't think it matters. I don't think I'm running it again. Okay. Nope, doesn't help. Does this change anything? Yeah, it does. But that one is not affected anyway. That's so odd. What? So weird. Trying stuff out. Whoa, whoa, whoa. That's really bizarre, to be honest. Is it really just happening once? Yeah, no result if I put minus 10. But let's delete that one and put on this one. Nothing happened. Let's delete name. Oh my god, I'm silly. Ugh. Okay. We're all a bit silly that we didn't notice this. This is actually padding. It doesn't mean that it will have 10 spaces, but it means that name, whatever it is, will be 10 symbols long. So if it's not 10 symbols, it will put spaces, in Tom's case, 10 spaces after it to make it as long as it should be. And for profession, it will put 10 spaces before it to make it 10 symbols. But firefighter has how many symbols? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So since it has 11 symbols, this will have no effect. So we're a bit silly, that's all. So if I run this again, you can see the result. So minus puts it after and plus puts it before. It's, well, personally, I don't really use those, but if I did have to format it nicely, I would. So it's quite useful to know. So you don't need to, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on, because you can just use this. And now the difficult part, formatting numbers. As I mentioned, by default, whatever locale you have, you will be having numbers printed in that locale, but you can change it using global settings. So culture info is having a culture class, culture property, and if you change this property to a new culture, you can print numbers in that format. So, if I wanted to print numbers in the format that Dutch people do, you would create a new culture info and you would print, put a parameter NL. And this is actually pretty tricky because there isn't any like enumeration for those, no constants. So you have to look up for those yourself from MSDN, the documents that Microsoft has for you. So every time, I really don't remember any of those. So every time I just go and look for it. Anyways, we have effectively, we have six formattings that we care about that I would like to show you guys. And I'll put a breakpoint after each of those. This one is no longer interesting. Okay. So, actually I'll keep it. Okay. So if I do demo formatting, yeah, this is fine. Okay, the second. So if I do demo formatting, let's inspect the numbers that we have. Pin it, pin it, pin it, pin it. So since it's known what currency is in the Netherlands, when you talk about currency, it gets printed in euros. And when we talk about normal numbers, well, in Netherlands, they are separated by a dot, as you can see, for percent. And for floating point numbers or big numbers, they're separated with a dot and then comma for fraction part, but that's inconsistent for percent. So to be honest, I would have no idea how they do it in Netherlands because it looks inconsistent. I don't understand the separation for the thousands. It's confusing. It's really confusing, especially for percent part. Because, so anyways, F5 means that we have a floating point number. So when we format something like this number, so you see it doesn't even have to be a string. I can format a different number, a floating point number, a double, or a string, and reformat it into a different number. So here you can see that it got formatted into a string, and even though it had 4 parts, 4 digits after the point, now it has 5 because I put 5 number here. If I didn't put it here, it would be just this. So floating point number and floating point number basically means that I don't have those separators for thousands. I only have whole numbers and separated fraction in between. And I think practically this is the most common one used. This one is the perversion for financial people, I guess, when they like seeing those, but this one sounds more practical to me. So if you write n, it splits it in 1,000 sections. So this is a number basically by 3 digits. So we have 3 digits and dot, and then 2 digits. It would be 3 digits if it's a bigger number, and then if it's a bigger number, it would be separated like this. All right, but it's not, so let's keep it as this. And then again, since I put 5, it has an extra 2 zeros to make it a 5 there, 5 symbols after comma. Currency, well, Netherlands has this one, euros, like most Europe, and so you can print currency as well. And if you want percent, you can write P. Does it have scientific one? And yes, it does have a scientific one as well. If I write so I can write B, and exponential, I think, is what you meant. So if I go there, you can see the result is this. Now, if I change cultures, it will give me different results. Pretty much, percent should have changed too, no? Oh, it's last one changed, okay. So you can see the results here. And you can see that basically the major change that happened is that fraction is separated by a dot and 1,000 section is separated by a comma. So basically the opposite of what Netherlands had. Literally the opposite. And then it's inconsistent for percent, it's again different. So Netherlands is just weird notation for numbers. And if we have culture invariant, now there's an interesting thing about culture invariant. This was new for me as well. Look at the currency they have. You see the currency is now this funny sunshine symbol. I call it sunshine. And this symbol means that currency is unknown. Well, the number after percent means it's probably a fraction of percent, because think what number we had. We had 1, 2, 3, 4, 5, and this is times 100, and you have a percent. So take it times 100, and this is the percent, because percent is 1 is 100%. So 1.12 is 5.12 is 512%. So 0.30 is the fraction that remains. So 30 is the thousandth part of a number. So P5 means for a thousandth part of a number that it's this much. All right. Now, again, if no currency is specified, it's important to note that you will have this this symbol. And I honestly don't know how people treat it when they let currency be without specification, without indication for what country it belongs. I don't know what use case is this, but I would be scared if I saw it. I would be really scared if I saw the sign, because I would have no idea how much money that actually translates to. But again, you can see the way numbers are formatted. And as you can see, culture invariant and Great Britain are kind of matching, except for the percent sign. Again, I have no idea why percent has a space after. It's just weird. So the summary that we can make is that formatting is really weird and inconsistent, and you need to really try it out and know how it works. Anyways, last two formatting thingies. This one is quite popular if we want to do some countdown, you know. For example, a missile is launching and it would have something like 3, 2, 1, and then launch, right? So this is okay. This can be achieved with using the D symbol. So if I use D and then 5, it adds zeros in front to make it fit 5 symbols exactly. If I put D5, it fits 5 symbols, so puts 4 zeros in front of 1. And if I put this, it's equivalent. It will also print those. If I run it through, you can see the zeros. Padding with zeros. Padding with zeros, you could say, yeah. Padding with zeros from left is what this does. Right. And speaking of padding, I didn't demonstrate this, but I think I should. So if I do something like word, well, take a string, let's say a name, Tom. Again, I don't know why I mentioned Tom. And let's say we say Tom name dot pad left. So string has also those padding methods. And basically, if I want to add 5 spaces to the left of it, I can do pad left. And if I want to add spaces to the right from it, I can do pad right. This is actually very widely used for something like old databases. I don't know why, but in legacy systems I see this all the time, where people always strictly have numbers in strings and with padding. bizarre, I know, but that's how they do. It doesn't work with ints because what would happen to an int? I don't know what would happen to an int if you do pad left, but it wouldn't work. I mean, it's not logical to me. So this one would be space space Tom, and this one would be Tom space space. And if I want to go back, I can do pad right and trim it. So if I want to return to the original name, well, that's silly because it's already there. Var original. Oops. I can do this. So if we go through it, sure, I'll run again. Name is already, sure, name is already there, and Tom as well, so might as well remove. So you see, we initially, really hard to see, right? But I guess I'll pin. You can clearly see the two spaces in front and the two spaces after. And the original, so pad left adds spaces to make it 5 positions, then if it's more than 5 it ignores. Pad right adds enough spaces to make it exactly the symbols you specified, so to the right. And if you do trim, whatever symbols to the left or the right, it will just cut off and keep a clean string without any tagging symbols. Quite useful. So the name minus 10 way for padding. No, it depends. If I pad a string as a whole string, this big string name, I just want it to be exactly 5 symbols always, or at least 5 symbols, then padding is the way. But if I'm writing a sentence like this one, a full sentence where I try to insert strings in, then minus 10 or 20, those numbers in interpolation of string is better. So use this when you have a sentence and you insert pieces of string, and use this when you take the whole string and shift it 5 spaces left or right. Trim doesn't really remove all spaces, it just removes the ones at the start or end. If Tom had a symbol in between like this symbol would not be removed, only the ones from sides. Next. So, string equality. We mentioned. Now, I would say this. I'll collapse this and I'll collapse this. I would say that now I'll demonstrate the most useful string thingy, which is joining and splitting and replacing. This, my friends, is something that you'll be using a lot. A lot. A lot because files are often messed up and we need to clean them up. And files are usually separated consistently, so we need to split them consistently as well. And for this reason, we have 2 friend methods, join and split, and one more, replace. And it's really self-explanatory what each of them does. Join basically takes an array of strings and combines them into a single string. So if I have 4 names and do a string join by a comma, the result is a single string with all those names joined by a comma. Let's do a demo. Joined and this one replace missing something. Cannot tell what I'm missing. Right, and this one split. So like this. Okay. And the third one, not the third one, but the fourth one, I'll just print it. Joined. So if you run this, you can see what each did. So string joined the names by a comma, and when I did the joined names and replaced them with a comma, when I wanted, why is it so many commas actually? Confusion. Why is it 3 commas and there were 2 commas? Right, because this was supposed to be array, I think. Yes. Comma, comma. Oh, okay, I see. So we replaced a comma by a comma with a space. So this is the mistake that I made here, and the rest is fine. I'll run it again. Expected. Okay. So we replaced a comma by a comma and a space, which basically formatted them a bit nicer, because, you know, after a comma you should put a space between words. And you see in the end it didn't put a space, so it's smart enough to know how to join and how to replace, and it replaces nicely. And if we want to return to the original or to join them into a single string, we can do, sorry, or to return them to the original array, we can do split. So it will split them by a comma and a space. So imagine that those are eliminated and you have an array with those elements. And we finally print them. So if I debug again, close this, we can see that array here has nicely put names, just like the original. We put the names back into the original array as it was before. So the key point here that I'd like to show, don't mix it with join that is here. Don't join a string like this, because this one is asking for a different array of strings. For a different array of strings. And something else, I guess. Well, it's a completely different thing, my point, and you don't need to know about that one yet. So to join two strings, we need to use a static method. To join not two strings, but to join an array of string elements, we need to use string join. And then we need to say what separator we use to separate those strings. And another key point, if we don't want any separator, if we want to just concatenate them, this won't work. Because there is no such thing as an empty character. There is a thing called an empty string. So if you want to join them by an empty string, you do this. An empty string exists, but an empty character does not. Next. So string join, replace can be called from the string itself, so can split. Replace and split can be called from strings. Replace takes old value and new value, so you replace the old value with the new value, and split takes a separator based on which you split the string. So minimal stuff that you need to care about, it handles. Any questions? Let's move on. Right. So how do we compare strings like we would compare numbers? Not equality comparison, but comparing which string is bigger and which string is smaller. Because if I do this, so we have string A and B, and we want to see which string is bigger alphabetically. If A is more than B, you see, we cannot do anything because it says operator more cannot be applied to operands of type string. So what do we do? And the answer is compare to. This one doesn't even work. You see, it's an error. So forget about the more equals, the more or less sign. Only equals works for strings. If you want to say which string is bigger and smaller, you need these boys, bad boys. So if A equals -1, sorry, if A to B equals -1, it means A is less than B, if A to B equals 1, it means the other way around. And if it equals to 0, it means this. So if I run this, I'm not putting this in the demo. Sorry, this compares A to A. Let me restart again first. So obviously, if I do the comparison, A is less than B because it starts first. So that is true. So compared to returns -1, if the first one is in less in alphabetical order than the second one, and the compared to if it's equal, it returns 0, and if it's more, then it returns 1. So -1 if it's less, 1 if it's more, and 0 if it's equal. Sure, I could. So let's do the other way around, B to A. Oh, you meant the variable names. There is B to A as well, you see. A to B and B to A. Oh, you mean, god damn it. I get it, what you mean now. B to A, B to A, A to A, A to A, okay. Zero, right. How is it comparing the strings? Basically, it takes one character at a time and does the characters comparison in their numeric values. So, don't know why I can't run it. Doesn't matter. Yeah, so it takes Unicode characters and compares them. Unicode codes, Unicode, yeah. So it compares character by character. When it finds that one character is less or more, it stops. If it's equal, it continues to the next character. So if you want to do something like sorting words in alphabetical order and you want to implement that by yourself, then you would do something like this. Are the return values of compared to -1, 0, and 1? And the answer is yes, it is. Comparing strings is case sensitive, yes. Of course it is. I can show you A to A. Const string A. So we have this. And you can see that it didn't print it. A to A. Yeah. Yeah, there is a way, but I won't show that one in this lesson. Yes, I will. I can show another example. So we have name. Kaisenau, Julian. Name 2, name 1, name 2, and we say name 1 to name 2, equality, Kaisenau, Julian. So we can do a switch here, for example, case -1. Name 1 is less than name 2. Break. Case 0. Name 1 is name 2. Break. And case 1. Name 1 is more than name 2. So we print that. Okay, so let's see what it prints. It printed name 1 is more than name 2. Because Kaisenau starts at earlier than Julian. Yeah, you can compare emojis too. Yes, of course. Let's do it. And let's see. Emojis. Put this to function. Static void compare string words word 1, word 2, I mean. And do the result. String. And let's be fancy with string interpolation. Actually, here, I cannot show that. Okay, word 1, word 2, paste it, paste it. Okay. Okay, so we have this, we have this, we have a compare. And let's compare some emojis. Don't know how they'll look like. Let me paste a random one. Let's call a smile. Let's call happy. Laughing. Which one is bigger, smile or laughing? What do you guys think? Let's try. Unfortunately, it didn't print, but it didn't print because I need to set the settings. But we can still tell which one is bigger. So word 1 was the smile, and word 2 was laughing. So word 2 is bigger than word 1. So laughing comes first. Sorry, laughing comes confused now. I mixed the other one as well. If it's -1, A is less than B. If it's 1, A is more than B. B is more than A. Is what this meant. Okay, good. No confusion. Okay. CC and CCC. I think this one will come first. Well, this actually makes sense. I mean, smile comes before laughing, right? And what did Aurora say? Laughing comes after smile. Okay, yeah. So I guess you would compare, you would say, okay, so the two symbols match, and then the third one you compare. The third one doesn't exist. So let's say it has Unicode 0, and this one exists. So whatever exists is less than whatever doesn't exist. And that's why it's less. And how do you print stuff of Unicode in console? Let me quickly have a look. In C#. Right, we need to set the formatting. Oops. Let's see how Smiley looks in a console. Okay. Holy crap. Unicode, I meant. Text.encoding coding. Right. Still not. Maybe. Nope. One more try, and if I cannot get it, so be it. Nope. Okay. I don't know why. I don't know how to print a smile in console. Shame on me. All right, let's get the Unicode then. So those are characters. So we can turn them into Unicode. So whoa. That's so weird. Okay, I'll keep this for the next time to figure out. Now let's not waste more time on this. Const string for int. Right. But I don't think it will help. Maybe. Maybe it's something. Still. Characters in literal. So an emoji is not a single character, as it seems. Emoji is not one character, it seemed. Or maybe I need to have formatting settings or something. I don't know. But it's different than we think. Anyways, it's not the purpose of this topic. The purpose is comparing things. So when thing is less, so A is less than B because it starts first. So when things are less, it's -1. When things are more, it's 1. B is more than 1 because it's higher. Soon, Kahoot. Yes, Olaf. Next. Actually, 2 more things before Kahoot. Since the last lesson was a bit shorter, this one will be a bit longer. So, a little bit about array and how we can take strings from substrings, a cut of a string from a string. So here is a simple string, hello world. Nothing special about this one. But we can do array slicing like Catgirl Aurora said. If I say substring 6, what it does, it actually goes 1, 2, 3, 4, 5, 6, and all the string from this position 4th will be taken out in the result. So let's keep printing the result. Okay. Print the result a bunch of times. Okay. Let's run and explore the results. All right, so what happened? The first one outputted world, because we started at here and the whatever remained got back in the return. So result is world. The second one said, okay, I start at 0 and I take 5 symbols. So 0, so 1, 2, 3, 4, 5. 5 symbols results in hello. That's the output. Third one said, okay, I start at the beginning and I stop at 5. So 1, 2, 3, 4, 5. So I take all from 0 to 5th index, but exclusive, or length 5. So these two, basically 0, 5 and dot dot 5, are the same. Way shorter to write the same. If I start with with a number and then continue with dot dot, it will be equivalent to substring 6. And in C# we have this symbol. If we do something like this, this means this is the end of array. So this is exactly the same if I did word length -1. So this is the same as this. Word.length -1 is the same. So if I do this and 1 or 2 or 3 or 4 or 5, it means I'm at the end. So take this as the end. And go back by this many things. Start, step, stop. There isn't such thing as start, step, stop, as far as I know. But yeah, but there is a thing called linQ, but about that in the future. So this one says, okay, I come to the end and I go one step back. So the end was the exclamation mark, and one step back is everything except exclamation mark. So I go from 0 all the way till the end except the exclamation mark. And that's what this means. And for this one, it says, okay, so I'll take everything that comes after a symbol before exclamation mark. So what's left? Only exclamation mark, because it's the last symbol. So if we want to take the last symbol, we do this. And finally, if we want to take everything except the first symbol, we can do this. From first symbol, well, all the way to the last, and I also ignored the exclamation mark. If I didn't put this, then it would mean that I ignore, I take the exclamation mark. Right. So, and the interesting thing about the this part is that if I have, for example, numbers, so I have numbers like 1, 2, and 3, and something like numbers like this. It means exactly same thing like for a string. Like I take the whole numbers array except the first one. So if you look at here, the second one is 1, 2, except the last one. No, sorry, not the first one. So if you see here, it's 1 and 2. So we removed this one. Quite neat. To place it in result. Of course it can be done directly. You don't have to place it in result. I can place this in here as well, if you wish. And you can see it's the exact same output. Now, let's continue. So that's how you substring. Okay. This one is a really cool one and a really interesting one. And I'll demonstrate it in two ways. So let's say we have a huge string of 1, 2, 3, 4, 5 of 100,000 elements. So a string array of 100,000 elements. And we want to concatenate all the elements of that string into a single, or more like we want to add hello testing string to that string 100,000 times. So we add something 100 times to the same string. So string builder took, so for this purpose, I will be using mass. I'll be using just raw string addition. Start, stop, reset. Oh, I actually have that already. Okay. So first, how would we do it before? Before, we would have like an empty string. We would loop through it and add. Is it adequate? Yeah, okay. We would add it 100 times over with a plus equal sign. And it works, but the results are quite astonishing. those are not the results, sorry. So if I run this, you see that it's not performing very well. And it's not performing very well for one reason. It's loading, 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 loading. I could have an elevator music right now. So here's the shocking thing. String builder, the thing that you don't know, took 2 milliseconds for the same thing. And concatenating string like this took more than half a minute. More than half a minute. Can you believe that? It's quite a big difference. So you don't want to ever do something like this for big strings or for strings that have that are in a loop. If it's in a loop of 10 or more already, move it away from a normal string. Put it to a string builder. So now, what is a string builder? It's just an object, a class, that manages adding, concatenating strings together. So if you do string builder append, it will append this line, this string, into itself. And it keeps it, it stacks it. So it stacks, it stacks, it stacks, and eventually when you want to use it, you do SB to string. So if I did SB to string, it would print the result. It would print 100,000 times over testing string. It's not a linked list, it's still a single string. I don't know what it does under the hood, nor do I care. It just works way faster than concatenating strings with a plus sign. And it works way faster, and I'll show you why. Actually, I'll show you a bit different things as well. Even if you do something like replace or join string, like a massive string, a huge string array, if you join it, if you append it, it still helps to improve the performance. You see here I have string builder and append string, basically what we did, right? And here I have a string builder which replaces characters. For example, you had a huge document, let's say hundreds of thousands of words, and you had to replace some characters. For example, you want to troll your friend and replace all A characters with a smiling emoji. You can do that with string builder, you can do that with string as well, but it's much faster with a string builder. And I'll show you that. I actually have prepared a benchmark that I am about to run, so we can compare everything in a nice way. First I'll remove this one. Actually, yeah, I'll remove this one. Yeah, this is fine. And I'll remove this one, and I will add this one. So benchmark runner is a class that can be used to run benchmarks. The way to go for benchmarking in .NET, I will actually select release mode because we don't care about debug mode. We want to have optimized code. So what benchmarks am I running, you might ask? And I'd like to compare join, replace. So joining and replacing with string. not only operations that happen in a loop, but operations for a large string. So here is the input. The input here is hello 100 times over in a single string. So I have a hello 100 times over in a single string, and hello in an array. Is it a rule to use string builder when concatenating strings over using plus equal? If it happens in a loop, it's a rule of thumb, yes. If it happens once, you don't care. Right, so benchmarks are running. Soon we'll have the results. Again, the input is hello printed 100,000 times. Actually, 1,000,000 times. And that's why it's running so slow, probably. And another input is words array, also 1,000,000 times of words array. So soon we'll have the results. So we try to do the same thing with string and with a string builder. So we don't do these, but we do these. So we okay, one more is done. So first thing, string join. We use string builder to join words array and return a string, the result of it. And then we do the same with a string from a string class. We do a join for a words array, and then we do a different thing, but for this with the same thing for two different classes, in two different ways. So we have a words string, so a single string with hello printed 1,000,000 times over, and we want to replace it with a B symbol. We want to replace H with B. So we do it in a string, and then we do it in a string builder. And let's see how long in each did it take. The benchmark is still running. But this is a very accurate benchmark because it runs it, as you can see, multiple times, I think 100 times over, so that it can average out the results and do a professional comparison that is unrelated to technical things. All right. So here are the results. There were some issues for string. I don't know why, but doesn't matter. So if I did string builder to replace a bunch of characters in a string with 1,000,000 characters, here are the results. It took 20 nanoseconds for a string builder to do that. And it took a crazy amount of time for a string. Literally thousands of times more compared, tens of thousands more compared to string builder. So if you're working with large strings, that's literally a no-brainer and a way to go. So yeah. And I wanted to show one more benchmark, and the question was, oh crap, it crashed. Visual Studio. So the question was when to use which, and I'll answer soon. Actually, I won't answer that question. Benchmarks will answer that question. Because who cares about my opinion? However, the results don't lie. So we have concatenation, our old concatenation with plus equals, and we have a concatenation with, string builder. And we have input, a number, how many times it happens. So if I pass 10, it means there will be 10 hellos in a string. And we are going to measure how long does it take to concatenate 10 strings. So 10, 100, 1 actually as well is probably interesting. And 1,000 is definitely enough to stop at. So 1,000 times, 100 times, 10 times, and 1 time. Let's run. It should run fast now because there isn't many times needed for this. And meanwhile, I'll prepare the Kahoot link. Place. Kahoot, link is there waiting. It's really productive to wait while benchmark is being done. I'll wait till the benchmark is over. And we'll find out what's the crossing point when having a string versus string builder starts mattering, starts being important. Soon. It's for the science, guys. Next lesson, I'm saying in advance, will be about files, input and stuff. Question. Actually, it's a bit loud. I'll hold some. string builder basically have the append method to make them in a loop and then to string to use them. Yes, that's correct. So here are the differences. Doesn't make much sense, this actually. It's the opposite. Maybe I mixed the methods? Yes, I mixed the method names. Okay, sorry guys. The method names are swapped. So this is string builder and this is string. So the method names are swapped. So it does make sense. So string builder is here. So when we take one concatenation, string builder itself has an overhead, and thus it's slower than just one concatenation of a single string. If we take it 10 times, it's still... Sorry. I hope it's better. So, one string concatenation is not worth it to use a string builder, because creating a string builder has its own overhead. 10 concatenations is basically the crossing point. Oh, you can still hear it from the stream. Oh god. I muted it, sorry. Okay, sorry. So from the start, a single string concatenation is 10 times faster than creating a string builder, because string builder has an overhead. It's an object, so we create an object and all the insides, all the internals of it, it needs to be initialized. So obviously it's slower. If we do it 10 times, however, it starts shifting to the side of a string builder. So 10 times is like the borderline of when you should start using string builder. But if we take 100 times or 1,000 times, the difference starts shifting tremendously, and you can see that it's really a no-brainer to use a string builder whenever you have a loop, just to be sure not to waste the performance where it matters. So I hope it is a good explanation. Now let's continue. I will go to volume mixer, maybe it'll help, I don't know. No music, okay. Let's go. Horrible title, but whatever. So in C#, there's no difference between char array and string. Don't answer yet. In char array, we have changes that can happen to the array. But for string is immutable. You cannot change anything in a string. You always create a new string. Now you can answer. Okay, I'm glad that there were so many who answered correct. String is immutable, char array is not. Next question. Well done, I2hack. If we print this, what will be the result? Will it result in 10 spaces to the left, or will it reserve the 10 spaces to the right? I agree that this one is tricky, but it will reserve to 10 spaces to the left. Because if we start I cannot even have a logical explanation why. Oh, that's a good remark. So the actual answer is false, and those who answer true is, yeah, that's a good remark. That's the the thing that we got on during the lesson as well. So it's a very trick question then. So yes, the actual answer is false then, because it will be 1, 2, 3, 4, 5, only 5 spaces, not 10 spaces. Wow. Next. So which of the two will return hello? Yes, someone with 2000 IQ answered correctly. The first one will not return hello because it will return world with a space, since it will start at 5th symbol and not at 0th as here. Roll-off is number 1. So remember, this is for the last index in array. And if this is the last index in array, which of the following is false? Or maybe all are true. "15 seconds remaining. It's a bit tricky to remember, but the first one, of course, is not true. The third one, it says returns all elements except first, which is true. The fourth one says returns all elements except first. Actually, this one is also false. I'm confused. Returns all elements except first. Returns all elements except first. This one is false because it will return all elements except last, not first. This one returns all elements except first. It's true. And this one, all elements except first. Oh, okay. Not all elements except first, because it will skip the first and last. Okay, sorry. Yes. So this one is false as well. So whoever picked the square did also okay. I don't know why I didn't mark it too. Yes. Oh God. Next. Is this array the same as this array, given that both arrays have at least one element? It basically means it starts at 0 and ends at 1. So this one, if I don't put anything, means it starts at the beginning and ends at 1. So it's the same. However, writing 0 when it's at the beginning is redundant. Next. If A and B are strings, then you can check if a string is bigger than B by doing which thing? A more than B will mean that A is what? If it's -1, it will mean that it's less. If it's 1, it means it's bigger. And this this doesn't, I mean, this by itself will just return a number. So if you want to check which one is bigger or smaller, you need to compare it to some number. Because this will just return -1, 0, or 1. So if it's bigger, it has to be equal to 1. That was the logic behind it. I think it's a poorly written question, so I'll keep that in mind next time. Roll off number 1. If A is a string, and we do A plus equal 1,000 times, what's the problem? Based on the benchmarks that we saw. I am not sure what happens with memory, and this might be true, but it's evident that it will be slow. So if we have to choose one of two, just pick this one for sure. Yeah, so since we haven't touched memory issues, you don't really know. And about this one we talked a lot, so we picked that one. Okay, string builder should not be used when? Josh once said that a new string will be created. Well, when you concatenate strings, a new string is created as well. You create it in both ways. So, 3 people selected concatenating a string in a loop. I guess they forgot to look at not in bold. You should not use string builder if you concatenate 2 strings once, because it's a waste of memory. About the string concatenation, it might be, but the more Problematic thing is that it will be slow. Why is it slow? It may be due to memory reasons. I am not sure why is it slow exactly. And for this one, if you concatenate in a loop, well, you should be using so. Should not is not the answer. All right. About memory, it will create lots of objects, that's true, but it won't take more memory. It will be just constantly discarded with objects creation. So, I mean, it won't take any more memory than it does with concatenating or with appending with string builder. But due to discarding those objects, it will be to waste and slow system down. It's a bad question, I agree, anyways. Carry on. Adding two strings at once, string builder, is not needed because it's a waste of memory overhead for creating it. So we have an array of strings, and how can we we have array of strings that needs to be joined in a single string. I missed the word string, so we need to join it in a string split by a comma. How can we do that? And remember that I said joining it like this is not the way to go, because it's a different thing. It's joining two arrays and not joining the different strings in a single string. So string join, this one is actually the one to go. Not this one, because string is first. The separator comes first. And a proof of that is result. So first separator and then the string itself. Next. What does string like this one return? D5. It doesn't depend on culture because there are no commas or culture specific things. It's a whole number, so it returns a decimal, a number which is with zeros in front to fill those missing gaps that are written after the word. Next. What does string currency return? Yeah, so whatever the currency is currently, whatever the culture is currently, it will be returned based on that. It will not return this because first of all, it needs a currency sign, so it's completely off. And it might return this, but only if we live in USA or in Australia or another similar country where dollar is in circulation. And yep. Which of the following will not fail if we are parsing to if parsing to an int fails, ignore the we. So we parse to an int and it fails. So which one will not throw an error, will not crash our application if parsing fails otherwise? Well done. Tuhawk, number 3. Well done. Aurora, 2nd. And Trolloff, number 1. Sorry for wrong parts, and most of you answered more questions than me in this one probably. Well, the first 3 at least, because I made errors there that I shouldn't have made. But it's a nice thing to learn as well. Hype, hype, hype. Give some hype, PogChamp, to roll off. PogChamp, PogChamp. All right. So the next lesson will be about files, input, output from a file to a file, and how do we process them, how do we write properly to them, and again, same problems, what are the common problems, things to be aware of, things to know. So, see you in the next lesson. Now, homework and Git itself. Homework is semi-complete. First part is complete and second part will follow tomorrow. So you can start it now. Let's see. Homework 7. This is the branch that you can clone. Basically, you need to make a table around a word. And in the tests, you can see examples how you make that table. So I didn't write a proper description, but I can show you input and output examples. It's in here. Nope, it's in here. Yes. Oh, God, terrible. Anyways, you can see it here. For example, if I input hello and 0, it means that it should create a table, basically border, not a table, border around word hello. If I input hello with a new line and then world, it should put a border around, and the border's length should be the size of the longest word. And they should be, the word should be wrapped around borders. And if I write 1, hello and 1, it should leave one space from left, right, top and bottom. So I think it should be clear based on the input. Based on the comments and examples in the task. What to do, and the test will say what to do as well. So yeah, you need to implement this method which says build text table. So build text table with a given message should return the expected output. That is the part 1. So you'll need to figure out how to put this string inside this frame border. And that's it for this lesson. Thank you everyone, especially Stuart for the $20 donation, and see you next time.